Okay, this again is the 26229 review number 6, and in this problem calculators are allowed. And if we read it, we see that it is a position, velocity, speed sort of problem. So the equation for free fall on a particular planet is s equals 2.8 t squared, where t is in seconds, and we're assuming a rock is dropped from a 550-foot cliff. First thing we want to do is find the average speed of the rock over the interval from 0 to 7. So, part A, we see the word average. That word average says that we should be looking for a secant slope. So a secant slope means we're going to need 2 points. This time interval, 0, 7, gives us x coordinates of those points. So if I plug 0 into the function, I'm going to get 0. If I plug 7 into the function, I'll get a 2.8 times a 7 squared, whatever that ends up being. So in this case, a calculator will be appropriate. So I'm going to turn on my calculator, I'm going to clear out what I've got, and I'm going to create a slope out of these 2 points. So on the top I have a 2.8 times a 7 squared minus a 0. Then I'm going to divide by the difference between the bottoms, 7 minus 0. Hit enter, and I see 19.6. So the average speed, notice it was a positive number, so I don't have to take the absolute value. That average speed is the same as the absolute velocity, was a 19.6 feet per second. So now let's look at B. B says I want to find the instantaneous speed of the rock. So for part B, because we have a calculator allowed, we're going to use the technique that we learned in class this week, and we will say that instantaneous speed, which is going to be the absolute value of the velocity, if it turns out to be a negative velocity, we'll have to change the sign, that will be my position at 4 plus h minus my position at 4 over h as h approaches 0. So if you recall on your calculator, we can put this in by first going to our y editor and putting in our 2.8x squared, and then going back to our home screen, and we're going to expand. So remember, expand is in your algebra menu. I'm going to expand, open the top of my fraction, the y1 of. Now we have an option here. What we kind of did in class is we let everything be a's and h's, and then we evaluated when a was 4. So I'll do it the way we did in class. You could choose to plug in 4 instead. So I'll do an alpha a plus an alpha h minus a y1 of alpha a, close the top of my fraction, divide by h, then I have to tell it what I want to expand with respect to, which is the letter h. Now that I've just put in my general slope, which is f of a plus h minus f of a over h. So I've just put this into the calculator when my function was the position function given in the problem. So now what I want to do is I want to evaluate this when a is the time that I'm interested in, which is 4. So I will go back to my calculator and I'll do the evaluated button, that straight up and down one that's down below my equal sign, and I will evaluate when a equals 4. Hit enter. This now gives me, back over here, it tells me that this is the limit as h approaches 0 of that expression I just got on my calculator. So 2.8h plus 22.4. If I plug in h equals 0, I'm left with 22.4. It's a positive number, so I don't have to take the absolute value, and my units again are feet per second. Last part, C, I'm asking for an average velocity. So again, I'm dealing with time and 2 points for a secant. So my times will be on the interval from 0 to 5. So I can get the 2 points by plugging 0 into the function and by plugging 5 into the function. Plug 5 in, I get a 2.8 times a 5 squared. So now my average speed, or my average velocity, they're the same in this case because they're both positive, will be the slope between those 2 points. So again, I can pull my calculator out and do 2.8 times 5 squared minus 0 divided by 5 minus 0. Hit enter, I get 14 feet per second.